everyone. This week's focus is on inferential statistics, and we are going to focus on t-test. If you look at this week's statistics, there is a data file and also there's a lab instruction. The lab instruction is pretty clear. It's open here. But just in case some of you would like to see live demo of how to conduct a t-test, I would like to give you a few minutes of short explanation of how to do this in Excel. Okay, so let's take a look at the first one, which is asking you to conduct a t-test for two groups of math scores. Okay, we want to see that whether the group 1's math score is statistically significant, higher or different than the second group. Okay, and which are the two groups? And it's really using the math anxiety. If the math anxiety is less than 30 or less, that belongs to one group, and the other group's math anxiety score is higher than 30. Okay, so this is the raw data file you will have. In order to separate them into two groups, we need to sort them first. Otherwise, it would be really difficult to choose one group at one click, right? So we want to sort the entire table according to the math and anxiety score first. Okay, you come here and then click on sort and filter. You want custom sort. Okay, custom sort, we want to sort by math anxiety, right? Sort by value from smallest to largest is fine, and click OK. Now you see the math anxiety score of these 40 students are sorted from the smallest to the largest. Okay, and after you sort your your cases, you are going to compare students' math scores, right? So in order to compare, it's really comparing two groups of scores and to see on average how their means are different from each other. So we need to do t-test to determine that. Click on your data type, go to data analysis. And there are, if you scroll down, there are 3 different types of t-tests. Here I need to explain something. When to use what type of t-test is critical. Okay? If your samples are dependent of each other, you'll use paired two sample for means. And I explained what dependent sample and what is independent sample, right? So for example, if the two sets of scores are related in some ways, if it's a pre-test and post-test, those are dependent sample t-test. You are going to run those. Why? Because you are comparing student A's pre-test score versus student A's post-test scores, right? So you are pairing the scores in terms of the subject or the student. So there is a connection between them. So the pre-test and post-test are dependent of each other. You cannot compare student A's pre-test with student B's or student C's t-test, post-test, right? So there is a pairing going on. In that case, you will need to click on the paired two sample t-test. And there are 2 different types of two sample assuming equal variances or two sample assuming unequal variances. These 2 are for independent sample t-test. For example, in our case, this is independent because we are going to use the first how many cases, let's say from 2 to this one is 13. So about 12 students whose anxiety scores are lower than 30. So we are going to use these 12 students' math scores and compare that with about 18 students' math scores whose anxiety score is above 30. Okay, because those 2 groups of students are independent of each other. They are not same person and they are not connected or not paired up anyway. In that case, we'll use 2 sample t-test. And in general cases, we will use unequal variances because for two groups, it's very rare the variances are same, right? And if you choose this one, which is what we are going to do for this case, and you will return the variance. You still remember from first week, the variance is the square of standard deviation, right? And it returns the variance value. And if you see the two groups are same, you will come back and run the t-test sample, two samples assuming equal variances, okay? But in default, we will run this one. You click on OK, and you need to write in the variable range, okay? And we do not want to choose the label because the label is only available for selection for the first group. So it will confuse the system because the second group does not have a label. So the labels should be unchecked when you run this, okay? And we just input the data range, okay? The first group is from case 2 until case 13, right? Up to this, the mass anxiety score is less than 30, right? And second group is click on your inbox first, and then it should be from case 14 all the way up to the end, okay? So you enter the first set of scores and then second set of scores, and you want to uncheck because you did not choose any label from the table. And then our alpha level is still set as 0.5, which is the conventional significant level we choose. And if you are doing medical analysis or something serious, you want this to be much smaller, okay? But in our case, it's fine. And then you want to choose output range. Where do you want the output to show on your Excel file, okay? I click on this and then click on here. And I would like my output range to show on starting the this cell, okay? So it shows your cell address, and then you click OK. So now you can see my t-test result. The variable 1 is really group 1. Group 1's variance is 231. Group 2's variance is 192 around. So those variances are unequal, right? So we did the right thing. We said those are independent samples, so those are two sample t-tests and assuming unequal variances. Okay. So the most important question is how to interpret the result, okay? There are two ways to interpret the result. First one, you can look at the p-value. If the p-value is smaller than 5%, in this case, which is, you can say you found, you can reject the null hypothesis. That really means there is a statistically significant improvement or the statistically significant difference between those two sets of scores. So you may wonder how you can use the other set, right? The t-stat is, on average, how those two sets of scores are different from each other. And we often compare the absolute value of t-stat with the t-critical value, okay? And there are two sets of p-values and t-critical values. And when to use which one, I want to touch base on this a little bit. If your hypothesis is directional, you should use the one-tail test result. If your hypothesis is non-directional, you will use the two-tail result. So one is directional, one is non-directional. I covered this in my lecture note. So if you already know, for example, the second groups is lower or greater than the not the other group, okay, the first groups, that becomes directional. The hypothesis is directional, so in this case you'll look into this one. So you compare the absolute value of t-stat with the t-critical value at the 5% point, right? So if the t-stat absolute value is greater than the critical value, you can go ahead and reject the null hypothesis. In this case, the t-stats absolute value is 3.27, and then this is 1.73. So it's clearly the t-stat is larger than the critical value, and then you can reject the null hypothesis. So as I said, there are two ways to reject null hypothesis, and I also have this in my week 2 debrief for the chi-square. Okay, so you would like to take a look at the debrief and see how to reject null hypothesis. Okay, and remember, null hypothesis always has equal sign in it. It assumes at least equal, or equal, greater, or equal or less. So if you are rejecting the null hypothesis, that means you're accepting your research hypothesis, right? Research hypothesis also means alternative hypothesis. So I hope this is clear to you. If you are still unclear, you can post your question in the Ask the Instructor forum, and I can answer your questions there. Okay. I hope you are able to run a t-test using Excel, and it's really sorting the data to make sure the two groups are can be selected in each group can be selected in one click, right? And then after you sort it, you can do this. And if you are comparing females and male students math scores, what you need to do is you will select or sort by sex, right? For example, we want to compare the math scores for female and male students. The hypothesis, people say, that's the computer score, right? Hypothesis is that male students do better in computer science than female students. In that case, you want to compare their computer scores, right? So in order to do that, you will need to go back and sort their data according to sex. Okay. So you see the female and male are sorted. Okay, so that you can in one click choose the female, one click you can choose the male, right? And then you want to compare their computer scores. So you come over here, and then you can just run the t-test. So that will be data analysis, and female male students, their scores are not paired, or they are not the same person's repeated measure. So you still choose two samples assuming unequal variance. Okay, and the first one is computer score up to here, right? The female students end up case 23, right? Here female ends here, and the male student score should start from case 24, right? This is case 24 all the way, and you didn't choose any labels. And output range, you choose the original, delete the original one, and for example this is the current one, and then you output over here, you click OK. It says the t-test two sample assuming variance output range will overwrite existing data. I'll say OK. Apparently I have some existing data there, but it's okay. So this one was original existing data, I believe. I can go ahead and delete that one. So this is our new one, right? So computer for female variance is 200, and the male variance is 359. So it didn't yield any significant difference between female and male, because if you look at the p-value, this is directional, right? Our hypothesis was directional, so we will look at one tail, and this is about 30%, which is way more than 5%. So we cannot comfortably say that the error to the mistake of because the mistake of rejecting null hypothesis is so high, we cannot comfortably say that the research hypothesis is supported. okay? And you know what p-value means, right? The p-value really returns what's the chance or percentage that you can be wrong by rejecting the null hypothesis. We cannot afford 30% of the times being wrong, right? So this is really not statistically significant. It has to be less than 5%. We can use that one, or you can use the t-stat. T-stat's absolute value is about 0.5, and critical value is about 1.7. So the t-stat is smaller than critical value. Therefore, you cannot reject the null hypothesis. So since we cannot reject the null hypothesis, we have to agree that there is not statistically significant difference between those two groups in terms of their computer scores, right? Okay, hope this is helpful. And if there's any question, as I said, post it and then ask at any time. Okay. I wish everyone have a good week of study. And it's hard to believe it's already third week of this class. Okay. Take care. Bye-bye.